Hello guys, so we are back again, and in this session we are going to continue with the Euler's theorem. And in this session we are going to do Euler's theorem for three variables. Okay, remember all the things which we did earlier were about two variables. We are doing here three variables. Keep this in mind. And here the things and the theorems are almost same. Okay, you can derive it similarly, so I'm not going to the derivation part. I'm just going to tell you the formulas. Okay, you will directly make out that what we have to do. The first formula is x dou u by dou x. You get an idea that here x, y, z, three terms will be involved. Keep that in mind because it is Euler's theorem of three variable. Like in previous it was x comma y. Okay, now y dou u by dou y, z dou u by dou z equals to what? N into u. So you can see almost similar, just one term came extra. Similarly, the next formula is not okay. Here you will not have that formula which was x square dou square u by dou x square 2xy dou square u by dou x dou y plus y square dou square u by dou y square is equals to n into n minus 1 into n into n minus 1 into u. So that formula will not be here. Instead here deduction. Second one which you are going to see is deduction. Euler's theorem. What deduction means? Actually it means the same thing, just represented in another format. The phase will just change, the work will be entirely same. So here it will be x dou u by dou x. You will see and you will say, yeah, it is almost same only. Dou u by dou y, z dou u by dou z, and here what you are having, n into f of u upon f dash u. So you can see everything is same, and they call it Euler's theorem for three variables. That's it. And either there is means the proof is almost similar, so I'm not doing the proof. Okay, you will say that it is just similar. What is the purpose of doing it? So I'm not going to waste any much time. So let's move on to the question. For this question, okay, here three variables are involved, so it will take more time when you solve this type of question. So the first question which you are going to come across is if u equals to x square y square z square the whole upon x square plus y square plus z square plus cos xy plus yz the whole upon x square plus y square plus z square. Prove that x dou u by dou x plus y dou u by dou y plus z dou u by dou z equals to 4 times this thing. Now you can clearly make out one thing is very obvious, that here first you have to write this thing. You know this thing combined cannot be a homogeneous function. Like when we were doing the questions, similar type of question appeared and we considered them u and w at different function. Similar we have to do it here, but the difference is three terms are there. So be careful of that. X square plus y square. First you have to do is write this thing properly, whatever it is given. You have wrote this. Now what is your next job? Tell the teacher that you are considering the terms. Let x v equals to, v is what? X square y square z square the whole upon x square plus y square plus z square, right? And w equals to what? Cos xy yz x square y square z square, right? Now put x equals to lambda x and y equals to lambda y in v x comma y. The moment you put, you would get v x lambda v. I will take out direct lambda power 6 lambda power square. The whole thing will be same only. Okay, what will happen here? What will actually happen here is that this will reduce, and here you will have what? You will have v of x comma y. So v of x comma y is a homogeneous function of degree n equals to 4 in variables. Listen carefully what I am writing. Variables x, y and z. Be careful of that. I am writing x, y and z. Understand, it is very important. X, y and z. After you do that, what you are going to do? Now you have proved it that it is a homogeneous function, so you can apply the Euler's theorem for three variables. So by Euler's theorem, remember you are not going to mention here that by Euler's theorem of three variable. Okay, it is not that much important. You can write it. You have to save time because you are going to attempt more questions. So x dou u by, what you are going to, x dou u dou v by dou x plus y dou v by dou y, z dou b by dou z equals to what is 4 times v. Let's call it a. Now let me remove this page. What we are going to do, put x equals to lambda x and y equals to lambda y in w x comma y. The moment you put, you will get w lambda x lambda y equals to what? Equals to cos of, here lambda square will come outside, and from here also lambda square will come outside, because you can see it is xy and yz, so square will come outside, here also square will come outside. So xy yz the whole upon x square y square z square bracket, lambda square will come outside, you are left with lambda power 0 w x comma y. Okay, now you will say w, so w x comma y is a homogeneous function of degree n equals to 0 in variables what, x comma y comma z. Sorry, here x comma y comma z will be there. Here similarly x comma y comma z. I think I did a mistake. Okay, if there was, okay, correct it. So in variables x comma y comma z, after doing this by Euler's theorem, what you can say? By Euler's theorem, what you can say? X dou w by dou x, y dou w by dou y, z dou w by dou z equals to, and n is what, 0 times w, which will be 0, which you will call b. Okay, you will call it b. Now if you see the proof, what you have, x dou u by dou x, y dou u by dou y, z dou u by dou z. What you are going to get? Let's write this. X dou u by dou x, y dou u by dou y, z dou u by dou z, which you can write x dou by dou x v plus w, y dou by dou y v plus w, and z dou by dou z v plus w. So we are going to get x dou v by dou x, y dou v by dou y, z dou v by dou z, and similarly x dw by dou x, y dou w by dou y, and z dou w by dou z. You have these values from a and b. So what you are going to do, put these values here. What you are going to have, you are going to have 4 times x square y square z square the whole upon x square plus y square plus z square, and here you will have 0 from a and b. Hence proved. Okay, now let's move on to the next question. The next question which we are going to take is this question. Hope you have understand that question. That question was just a simple classic question. Now the second question is, if u equals to x cube y cube z cube the whole upon x cube plus y cube plus z cube plus log xy plus yz plus zx the whole upon x square plus y square plus z square, proved that x dou u by dou x, y dou u by dou y, z dou u by dou z equals to 6 times x cube y cube z cube the whole upon x cube plus y cube plus z cube. Okay, now the first question which you should ask to yourself is that here log has appeared, so what here do we have to use a deduction thing? The thing is that if you have, means if you will little bit smart, every time when I use deduction in log, okay, deduction theorem, there was always if it was log x by y. I told you if log x by appears, you should use deduction. That is right, correct. But there is one condition. If you see that x, if you substitute x by lambda x and y by lambda y, and lambda cancels out, okay, then it is homogeneous. Why you need to do that then? Why you need to apply deduction? In all the log problems where I applied deduction, it was situation where x by y lambda were not cancelling out and it was coming as non-homogeneous, if you have noticed. So if you have not noticed, keep this in mind, because here you can clearly identify that here lambda square, lambda square, lambda square, here lambda square and lambda square, all lambda square will come out and they will cancel out. So do I go with deduction? No, I will not go with deduction. I will go with the normal Euler's theorem. Here it is very clear. I will go with the normal Euler's theorem because it is a polynomial function in the form x by y. Now, what we are going to do? We are going to write this thing first. Okay, you need to have crystal clarity why we are doing this thing. Okay, although the final answer may be wrong, I don't guarantee it. Okay, children make mistake. I do make mistake many times. You can see from my videos I make mistakes, but concept should be clear that what you are doing. You should know what you want to get from the question. Then automatically you will know the path to achieve it. But you should know what you need to find. Okay, that is the important and why we are doing that. Now let v equals to x cube y cube z cube the whole upon x cube y cube z cube, w equals to log xy yz zx x square y square z square. Put x equals to lambda x and y equals to lambda y in vx comma y. So v lambda x comma lambda y equals to, here lambda power 9 will appear, here lambda power 3 will appear, x cube y cube z cube the whole upon x cube y cube plus z cube. Lambda power 6 will be here and it will be what? V of x comma y. Now v of x comma y is a homogeneous function. Sorry, I again forgot to write this thing, which is very crucial. If you don't write that it's a 3 variable thing, you will get marks reduced. Of degree n equals to, you should write complete homogeneous function. Okay, I am saving time, that's why I am doing that. In variables, okay. Now what you should do is that you should do a thing which you do mostly by Euler's theorem. You should give it 1. Similarly, what you will do? You will go with w, put I forgot to write here z. The moment you do that, lambda z, you have to mention everything. Okay, and why we are putting here, sorry I forgot, z equals to lambda z. Don't forget anything. It's the side effect of doing that exercise. Okay, in 2 variables, if you do and do in 3rd variables, it feels okay, the mind gets in coordination with 2 variables. Okay, you feel very comfortable in 2 variables. So here what we are going to get, the moment I substitute inside the log, I can see lambda square will come outside, and here also lambda square will come outside. So it will cancel out and I am going to get lambda power 0 w x comma y comma z. So Now by Euler's theorem, you can see z dou w by dou z equals to what? It will be 0 times what? 0 times w, which will be 0. Let's call it b or second. Now if you consider the proof, what you can see is now we will just if you substitute the value, this value is 0 and this value is what? 6 times here you can see 6 times v is what? V is x cube y cube z cube the whole upon x cube plus y cube plus z cube. Hence proved. So we are done with these two questions in this session, and in the next session we are going to do some more questions on Euler's theorem of three variables, and then we are going to wind up this chapter, which is partial differentiation, and move on to maxima and minimum. Thank you. Revise these chapters. Okay, revise all the questions and this chapter till now, whatever we have done. Thank you.